Hello, today I am going to explain you how to model, analysis and design the G plus 3 story residential building. See, this is a plan view. Consider this is 5 meter, 5 meter, 5 meter along the length and 3 meter, 4 meter and 3 meter along the width. 15-meter length and 10-meter width. This is an elevation view. Consider 3 meter, 4 meter, 3 meter of 3 base and 2 meter from below ground level and 3 meter from ground floor, 3 meter first floor and 3 meter second floor. Now we have to model this in staad pro. Go to staad pro, create a new project here and select space. See, a space structure which is a three-dimensional frame structure with loads applied in any plane is the most general. For all the structures we are going to choose this space option only. Save the file name as residential building. Let me save the select the location for saving the model and the units be meter and kilonewton only, and go to next. Here I am going to choose open structural wizard and click on finish. You will display something here. Let me see that. See, here you have so many options. Click here. Here you will get truss model, frame model, surface or plate model, solid mesh, composite models, import CAD models, VBA macro models. Here we are going to choose frame models. In that we are going to choose bay frame. There we are consider length as 15 meter and height as 10.5 and width as 10 meter. And number of bays along length is, you can see here, from the plan we can see that length is along length is we have 3 bays, along height we have 4 number of bays, along width we have 3 number of bays. Each bay width is 5 meters, let it be same, and height would be first from basement to plinth, that is 2 meter, and again ground floor is 3 meter, first floor is 3 meter and second floor is 3 meter, and click on OK. Sorry, the entered value is less than the selected value, so that's why we have to select, we have to enter 11 meters height. Then we have to edit here from up to plinth beam, that is 2 meter, ground floor is 3 meter, first floor is 3 meter and second floor is 3 meter, and click on OK. And here we have to edit first bay width is 3 meter, second bay width is 4 meter and third bay width is 3 meter. Just click on OK, then apply. You will look and model like this. See, this is 5 meter, 5 meter, 5 meter width length and 3 meter, 4 meter, 3 meter width, and you can see by height. See, this is 3 meter, 3 meter, 3 meter and this is 2 meter. Then you have to merge this model with staad pro model. Merge model with staad pro model. Would you like to transfer or merge this model prototype to into staad pro? Yes, you have to click on yes. See, this is the plan view. You have 5 meter, 5 meter, 5 meter of 3 base length and 3 meter, 4 meter, 3 meter of 3 base width. Always we have to consider higher dimension as length and lower dimension as width. And this is an elevation view. From this you can see that from ground to plinth beam, that is 2 meter, ground floor 3 meter, first floor and second floor is 3 meters. Now the model it is asking paste protocol model. Just click on OK. The model has been appeared in this way. Now you can see the rendered view of this model, you will see only the frame structure. See the global axis, it is located in the opposite side of the building. The global axis is not located in this plane, it is located in this corner. Now we will go step by step procedure to model model the building and to apply the properties for the building. See, in setup we can go for job setup, client, job number, anything we want we can enter here. And then geometry. In geometry, x, y and z, it has been appeared at every node. See, the nodes has been highlighted here. Go to general. Now we have to follow step by step procedure. This is property, specification, support, loads and definition and material. Here we are going to assign the properties. First we have to define the properties before assigning. Go to define, rectangular. We are going to choose for this model column dimensions as 0.23 by 0.45 and beam dimensions as 0.23 by 0.35, and consider slab thickness as 0.15 meter, and consider main wall thickness as 230 mm and partition wall thickness as 100 mm. First we have to define these two parameters, that is column dimension and beam dimension. Now I am going to define these parameters. First I will define column dimension. See, this is YD, this is depth, that is longer direction, that is 0.45, and ZD is smaller dimension, that is 0.23. Just click on add. Now you can see the column definition has been added. And similarly we have to add beam definition, that is the change is only we have to decrease the depth 0.35 and the width will be same 0.23. Just add. First we are going to assign these two model, then we will assign the slab load. Select beams parallel to Y. All the columns has been selected. Just click assign to selected beams. Now click on assign. Just click on yes. The property has been assigned. See, this is R1. The property is assigned. Even you can see here the material, it is concrete. Now we are going to assign beam property. Go to select beams parallel to X, select beams parallel to Z. All the beams are selected. Just assign to selected beams. Assign. Now you see the rendered view. See, the properties are assigned for all the beams and columns. Now we have to change the orientation of these two columns. Because the columns are elevated to outwards and it look quad, even the columns will be projected to outwards, so that's why we are going to change the angle for those columns and select these columns. By holding the control key, select all these columns which we have to make a beta angle for this. Here we have now go to commands, geometric constraints, beta angle, just give it to 90-degree rotation. Just click on OK. See, the beta angle will be appeared. Now we can go for render view. The orientation of the columns will be changed here. Now you can see that there is no extra projection towards to outward side. Now we are going to assign the supports for this model. Just create and support, that is for concrete we are going to select fixed support, add and select on support. While selecting support, that the node cursor should be on. Just drag at the footing, go to isometric view and see the whether the all the columns has been selected or not. Just give assign to selected nodes. Assign. Yes, now the footings have been assigned for this building. Now we go for loads and definition. First we have to add load case details. Just add, that is primary loads. First we have to add dead load. Give title as dead load. Add. And second one is live load. Add. Just click on close. For dead load, add. We have to add self weight for this dead load because the load is acting towards gravity, so the dead load we have to give is -1. The self weight will be calculated by software itself, because while defining the properties we have given property as concrete. The software inbuilt will calculate the weight of the by using dimensions of the beam with respect to self weight. It will calculate itself the self weight for beams and columns. Just we have to assign the wall loads on these beams, wherever the wall loads will be acting on these beams. See how the wall loads will be calculated. See the main wall and partition wall. Main wall will be acting at the outer side of the building and the partition wall will be at the inner side wherever it requires. How to calculate the main wall loads? That is total height of the story minus depth of the beam into thickness of the wall into density of the wall. Here the height of the floor is 3 meter and total depth of the beam is 0.35. We have to minus with the depth of the beam into thickness of the main wall is 230 mm, that is 0.23 meter, and density I am considering as 20 kilonewton per meter, and total load will be 12.19 kilonewton per meter. Similarly for partition wall, 3 minus 0.35 into 0.10 into 20, 100 mm thickness I am going to consider the wall thickness. That is total is 5.35 kilonewton, and I am considering live load as 2 kilonewton per meter square and floor finish is 1 kilonewton per meter square. First we are going to add dead load, that is member load, minus 12.19 kilonewton per meter. We can see here 12.19 kilonewton per meter. Just add this. See the load has been added here, and again we have to add partition wall load. Let me see how much is the partition wall load. That is 0.31 minus 5.3. Just add this. We have to add negative sign for this because the load is acting towards the gravity. Just close this, and again we have to calculate the self weight of the slab. That is equal to thickness of the slab into density. How much the thickness is 150 mm, that is 0.15 into density is 25 per meter length. That is per meter length we are going to calculate. Enter. Per meter is 1 meter. Let's we calculate that 0.15 into 25. We'll get approximately 3.75. That is 3.75. We have to add dead load of slab here. add, that is floor load. How much we have taken? Minus 3.75. Here we have to enter the range, otherwise the slab load will be assigned only for at 0 level. Just click on add and then live load. For dead load I am going to consider floor finish also, because that is also dead load. It won't vary load for instantly loads may not change, so that's why. Then live load, add. Live load only on applied on floor, minus 2 kilonewton per meter square. Just add this, then close. Here we have to assign self load for all the columns and beams. Just click on assign to view, assign. See, the self weight will be assigned for all beams and columns. Then the question marks will be disappear here. The question mark indicates the load still at not assigned for any members. Then we have to assign this main wall load at only outer sections of the building. See, we are going to assign only first roof and ground roof on plinth beams. So that's why just drag these beams and go to view selected options. Go to view selected objects only option. Go to 3D view and go to top view. Then select only outer beams. Assign to view. Assign, yes. Now go to isometric view. Now you can see the main wall loads has been assigned at the outer beams. Then go to top view. Again then you select inner beams by drag, or you can click on and select. Just by using control key we have to select all these beams. Assign to selected beam option, select. Now you can see that all the main wall and partition wall load has been added here. Now we can see the whole structure. The top floor, the no loads has been added. Now you go for top view or isometric view, select only outer beams, because we are going to provide parapet wall load only at the outer beams on top floor. Assign to selected beams, assign, yes. Now we have to apply slab load for all the floors, because slab may be acting at all the floors and I am not going to provide floor finish for top floor. Then we have to define another one load. Just add this floor load. In top floor I am not going to consider any floor finish over there. Minus 3.75, only dead load of the slab I am going to choose. See, now we have to give range from where to where we have to apply this floor load with floor finish. Just from first floor roof we have to add this floor finish with slab load. Then select node cursor, double click there, then you can get an height of the floor till where we have to apply that load, that is 8 meter. Just close this, just enter 8 here. Now we can see that the load has been assigned for plinth beam and ground floor ground floor, first floor, and second floor. Then again we have to add this load to top floor, that is 11 kilo 11 meter. Minimum is 11 and maximum is also 11. Then change. The load has been assigned for top floor. And live load I am going to assign for all the floors as same. That is 0 to 11. Now the live load has been assigned for all the floors. Now the modeling has been completed with assigning of loads. Now we have to make a combination of loads. Go to load case and load case details. Add. Here you have load generations, define combination, auto load combination. Here you can go for auto load combination by selecting the codes. You can generate your load combinations according to the code provisions. Here I am going to define the combinations that may help me to design the columns and footings separately. Here we are considering factored load for column design, unfactored load for footing design. First I am going to consider unfactored loads, that is by default 1, and we have to transfer this load case 1 and 2 to this side and make an one combination. Then you have to make another combination, that is factor load. Then you have to send by default you have to choose 1.5 kilonewton as a safety factor. Send these two loads, sorry, send only these two loads to this side and just click on add. The load combinations has been over. Now you have to check the model, see whether you have any multiple structures. No multiple structures. Then check for duplicate nodes. No duplicate nodes. We have to make all these checks before analysis. Then go to analysis or print, just add this, then go for analysis, run analysis. The model has been analysis for all the load combinations. You will get 0 errors, 0 warnings and 1 notes. Close this. Go to post processing mode. Just click on OK. Here you go select an envelope and click on front view and select these nodes at the bottom. From this we can check the column loads and for factored and unfactored loads. Let me go to the report, support reactions along Y. For loading, first we will select unfactored. This is for footing design. Just click on OK. See, now you can see that 22, 42, 23, how many footings is there. You will get all the loads, that is 707 kilonewton, 495, 479, 311.110. For all these cases you have to design the footings. Even some cases the movement will be more, even movement also consider for footing design. Similarly, go to report, support reactions, FY, and load cases and select factored load. Just click on OK. You will get an factored load here, that is 1061. This we have to use for column designs. By using Excel sheets or by manually we have to design those columns and footings. From software itself we can go for design. That is, one procedure is, here you have design procedure. We have to choose concrete here and IS 456 as a code. We have to define the parameters. That is concrete. First we will consider a concrete. I am going to consider 20, 30 grade or 25 grade kilonewton per meter square. Add yield strength of the steel, that is main steel. I am going to consider 500 grade. Add this. And sectional reinforcement I am going to consider 415 grade. Maximum main reinforcement I am going to consider 25. Maximum sectional reinforcement going for 12. Minimum main reinforcement, that is 10. Minimum sectional reinforcement will be 8, and the ratio is 4 kilonewtons or 4%. I'm sorry. Just add this. We have to assign all these properties to the building. Beams and columns both will be concrete members only, so we have to assign for all these members, and we have to assign for all these because steel will be applied for beams and columns. So that's why maximum and main reinforcement everything we have to assign for a whole building. So that's why we have to select assign to view option. It will assign for all structure. Then go to commands, design beams, add, design columns, add, and take off. Take off means print the total volume of the concrete and weight of the steel reinforcement for the beams, columns, and elements designed. Add. Now we can see that design beams. Which are the beams we have to select, that which are the beams and which are the columns here. Go to isometric view, then you can see all the beams are selected or not. Go to assign. Now we have to assign for columns. Go to select on Y, assign, yes. Now you go for perform analysis and print once again. Just add this and go to analysis, run analysis. You can see that the analysis has been running, but it will take quite late because we are going for designing also here. See, 0 error, 0 warnings. Go to view output file. The results has been outputted. See the concrete design results. What we have considered, that is FC2 FC and the aggregate of the concrete is 25. Main reinforcement as 500 grade and 45 415 grade as FI sectional. See the design for beam number 1, and the dimensions has been as considered is mentioned here, that is 230 mm by 350 mm, and cover of the concrete for beams is 25 mm, and length of the beam is 5 meter. It has designed for beams. Similarly for columns, it has designed for columns also. Required steel, required concrete area. Main reinforcement provided is 8 of 12 dia, that is for 0.87%, equally distributed, and tie reinforcement provide 8 mm dia rectangular ties at 190 mm center to center. As per this reinforcement details, you can provide more reinforcement also, like by increasing the sides size of the bar, you can minimize the number of the bars in the columns. See here we got 8 of 12 dia, 8 numbers of 12 diameter bars. That means you can reduce for the 16, and by using 16 you can go for 4, by using 20 you can go for 4, by using 16 you can go for 6 number of bars, you can reduce. Like this the column reinforcement and beam design has been calculated. This is dia of the bar, weight in the here, the total weight of the steel has been given, and even the volume of the concrete required in cubic meters it has been given for the structure. This concludes this tutorial.